Hi everyone. Today here in this video we would like to talk about the color code of a resistor. First of all, resistor is someone who is having some resistance which is opposition to the flow of the current. So every resistor will have some resistance. How do you identify what is the value of the resistance that the resistor has? For that it has a color code. Like it is being shown in the diagram, this is how a typical resistor looks like with certain bands. So if you draw any diagram for resistance, I'm just drawing it for the convenience again. Say this is a resistance. Then it will have bands or else a color codes on the top of it. It could be like this, one color here, just like a band around it. There is another color here, and of course there is another color here, and little far at the edge of the second edge of the resistor there is another band. It is like this. Typically in a simple way it will have something like 4 bands like this. So basing on the colors that is being coated or painted on the resistor, we can identify the value of the resistance. The first one, band 1, is the digit 1 value of the resistance. The second one is the digit 2 of that resistance. The third one is actually the 10th power, the multiplier actually. The fourth one is, here we have is the tolerance. Tolerance means the kind of the error that is possible. First of all, we'll talk about the tolerance itself. Say, let's start talking about this tolerance itself. That means I'm talking about the fourth band. So if you are talking about the fourth band first, that could be having a color like gold, which means the error in the given value could be plus or minus 5%. That fourth band could be in silver color itself. That could be saying that it's having an error of plus or minus 10%. Sometimes, which may not happen quite regularly, there is no fourth band itself. It means it's not at all accurate. It's having a plus or minus 20% of an error. So if we are looking for the best possible kind of an accuracy, we shall find something who is having a gold band, which says that you say there is a value of some 400 resistance, but still because of any of the practical reasons it could be having an error of plus or minus 5%. See, there will be always say kind of errors or approximations. So this much of approximation we shall be fine-tuned or we shall be prepared for when we are looking for the value of a resistance. It cannot be absolutely a given value. So that's about the fourth band. So it could be gold, which means there is a 5% plus or minus. It could be silver, which means a 10%. There is no band of fourth band itself, then it is having an error of approximately some 20%. That's about the fourth band. And then the first band, if you talk about the first band, and of course second band, first color and the second color. Of course the same is the case with the third band, but third band is the value of 10th power. So there is certain colors and that colors represents a particular value. Each color represents what value is the point that we are going to discuss here. So we will discuss what is the digit and what is the respective color is. That's the point that we would like to learn. That means if the digit is 0, then that's being represented with black color. If it is 1, it is represented with brown. If it is 2, it is represented with the color red. If it is 3, if the digit 3 has to be represented, it is done with a color orange. If the fourth is the digit that you want to represent, then you shall represent with yellow itself. If fifth is the color that you want to represent, then that is nothing but equal to green. If sixth digit that you want to refer, then that's nothing but equal to blue. If seventh is the digit that you want to represent, then it will be equal to violet. Eighth similarly represents gray. Ninth represents white. So you shall know this list, you shall remember this list, so that basing on the color written, we can just decode it into digits. See, for example, let's have a look at the this diagram that I have drawn. I have drawn some diagram, right? What is the resistance of this resistor, if somebody asks? You shall look at the digits. Look at the first digit. The first digit is being drawn like green. So what's the value of the green? If it is a green, it represents 5. That means here the digit 1 represents 5. Second one is orange. Look at the orange. Here is the orange. Orange represents the digit of 3. So that is 5. And this represents 3. The first one represents 5 because it's green. Second one is orange, that represents 3. Next one is, see, look at the third band, that's blue. Look at this, this is the blue. Blue is a 10th power, so look at the blue. Blue represents 6. That means what? The third digit says whatever the value that we have, 53, 5 and 3 into 10 power of 6. And look at the tolerance. I have written white, I mean to say it's like a silver, which is having an error of plus or minus 10%. So what is the value of the resistance that I have drawn here? So you can say first one is green. So the green represents 5. Second one is orange. Orange represents 3. The third one is the multiplier of the 10th. The multiplier of the 10th is nothing but 10 power of 6. And of course the band is of silver, so plus or minus 10%. Be careful, it's not 10, but it is 10% of the total value is the resistance. This is how we can color code a resistor, right? So now we can do one thing, like there is another diagram here, this diagram. Let us see what's the color code of this diagram itself, just for the sake of an understanding. So look at the first color. The first color that is being here is the yellow. So that's digit 1, yellow. So what is that yellow? Look at this list. Yellow is 4. So this represents actually 4 for you. See, what's the next one is? It's like gray. This is the second one, gray. So what is that gray? No, it looks like brown. It's not gray, it's brown. Yeah, brown. So the brown has a value of 1 itself. So 41. Next one is orange. This is orange. Look at the orange. Orange is 3. That means what? 41 into orange is 10 power 3 into 10 power 3 into 10 power 3. The last one is in gold color. That means plus or minus 5%. So what's the diagram value? What's the resistance of the diagram is? The first one is yellow. So the value of that resistance is equal to value of resistance in diagram. First diagram. Yellow means 4. Next one is brown. Brown means 141. So both the first digits and second digit represents the value itself. The third digit represents the 10 power, that's orange. Orange is 10 power 3. and the last one is golden color and it's having an error of plus or minus 5% resistance. This is how we can decode the resistance values basing on the color code drawn on them. So when a company manufactures a resistor, it will give the value to the customer basing on the color code like this. So how do you know? 0 is black, 1 is brown, 2 is red, 3rd is orange, 4th is yellow, 5th is green, 6th is blue, 7th is violet, 8th is grey, 9th is white. Now, how do you remember this color code? There are different colors. So, to remember this color code, we can simply have an English sentence. How to remember this color code? To remember this color code, we can have a sentence. Sentence is like this. B. Roy of Great Britain has very good wealth. Somebody say wife. Why shall we say about the wife of someone else? So I am talking it like wealth. So let's look at the sentence, right? Look at that carefully. B means block, which represents 0. Another B, that's brown, that represents 1. In the Roy, take only R, red, that represents 2. That represents 2. And then of is just a word used to make a sentence, like, and then we have G. Okay, now we can say in the case of, in the of, we are having orange. Just a minute. Yes, in the BB Roy, first B for brown, black, second B for brown, that is 1. Then R represents red, that is 2. And this O represents orange, this one, that is 3. Y represents yellow, that is 4. Half is an extra word that we have used just to make it like a sentence. And then G represents green, this one, that's number 5. Then Great Britain, in the Britain B again, this B represents blue, that is 6th. Has is just again an added word for a convenience. V represents violet, that's nothing but 7. G again is nothing but the grey, 8th, has a wonderful wealth, great wealth. That W represents white, that is 9. So, if you are a little worried about how do I remember this color code, just remember this sentence. What is that sentence is? The sentence is simple. I will write it once again for your convenience, right? The sentence is like this. B represents black. Another B represents brown, R represents red, O represents orange, Y represents yellow, of has no physical significance, and again great, where G is only having a significance, and again Britain, so in this G represents green, in this Britain B represents blue, has no significance, very, I am writing non-significant words with the white colors so that it becomes easy for you to identify. This V represents violet, then good, very good, where this G represents grey, and finally wealth, where W represents white. So BB Roy of Great Britain has very good wealth, which can be decoded as 0 black, 1 brown, 2 red, 3rd orange, 4th yellow, 5th green, 6th blue, 7th violet, 8th grey, 9th white. This is how he can decode a resistance tellers and identify the value of the resistor that's given to you or shown in the shop. Thank you for watching.